Hi guys, in the previous video we have already discussed about thermochemistry, and we all know that thermochemistry is a branch of chemistry that deals with heat exchange. Heat exchange can also be called enthalpy change, so we would be learning a new word for the energy change or the heat change or heat energy is now going to be called enthalpy changes. And this video is going to deal with the enthalpy changes that are going to take place in a system. First of all, we need to understand that enthalpy change can be involved not only in a chemical reaction, but it can also be involved in a physical change and a nuclear change. There are three types of reactions that can take place in this universe, and those can be physical reactions, chemical reactions, or nuclear reactions. Chemical reactions we have already discussed earlier, but we will be discussing more about chemical reactions. Let's go over what is a physical reaction and what is a nuclear reaction. How is enthalpy change compared among physical, chemical, and nuclear changes? We all know what is a system and surroundings, so let's take up physical change first. This is my system. Before that, we should know that enthalpy change can be represented with delta H. Delta always stands for change, and H is nothing but heat or energy or enthalpy. Now, what do you mean by a physical change? Physical change is when the state change happens. For example, if my liquid water changes to gaseous water or water vapor, this type of change is called physical change, and we all know in this particular change, heat is going to be absorbed by water. Or we can say that the system is endothermic. So in this case, your system is endothermic. Since we have surroundings around the system, and let's say this represents your surroundings are going to be exothermic. That means your surroundings have given heat to your system. So the blue represents the surroundings and pink represents the system. This is an example of a physical change. In a physical change or a physical reaction, energy is lost or gained. Who is losing energy is the surroundings. Who is gaining energy is the system. Remember that the energy loss, because law of thermodynamics says that conservation of energy happens. So here conservation of heat energy happens. So energy lost by surroundings is equal to energy gained by the system, is equal to delta H gained by system, because energy is always going to stay conserved. Now let's talk about the chemical reaction. So let's make the chemical reaction system. Let's take the same chemical reaction as we took in video 1. Carbon reacts with oxygen to gives you carbon dioxide, and this is called combustion of carbon. Because in a combustion reaction, energy is lost. So this will be an exothermic reaction. And the amount of energy lost is H equal to negative 393.5 kilojoules. A combustion reaction is always an exothermic reaction. Now, since this one is losing heat, somebody is gaining heat. And who is going to gain heat is the surroundings. This is the surroundings around this chemical reaction system. In this particular case, your surroundings is endothermic. So we have endothermic surroundings and we have exothermic system. From here, always remember, heat energy never ever disobeys law of thermodynamics, and law of thermodynamics says that amount of energy lost and amount of energy gained is always equal. So here delta H or enthalpy loss is from the system. So enthalpy loss by system is equal to enthalpy gained by surroundings. Always remember, enthalpy loss is written as negative value and enthalpy gained is going to be written as a positive value. Now let's talk about the third change. And that third change is called nuclear change. Always remember guys, nuclear reactions are the reactions that result in energy changes from the nucleus, not from the electrons. And nuclear reactions are of two types, fission and fusion. So nuclear fission is a reaction that is going to give out heat, and nuclear fusion is also a reaction that is going to give out heat. So nuclear reactions are always going to be exothermic. So in this case, your system is always going to be exothermic and your surrounding is always going to be endothermic, because only at a time one loses and the other gains. And as we all know that the energy loss and the energy gain is always equal. So delta H lost by the system is equal to delta H gained by surroundings. And this was about our nuclear change.